Jupiter, the mighty gas giant, looms large in our solar system, its sheer size and magnitude making it one of the most fascinating objects in the cosmos. Roughly 1,000 times larger than Earth and rotating once every 10 hours, Jupiter's turbulent atmosphere and ferocious Coriolis forces create winds and storms unlike anything we experience on our own planet. When one of the most celebrated astrophysicists of our time, Neil deGrasse Tyson, speaks about Jupiter, he does so with both awe and reverence. His ability to take complex cosmic phenomena and explain them in ways that anyone can understand has captivated millions. And when it comes to Jupiter, Tyson's revelations challenge much of what we think we know, opening new doors to understanding not just this gas giant but the very nature of our solar system. Jupiter's size is staggering. This colossal planet could fit over 1,300 Earths inside it, and despite being primarily composed of gas, its mass accounts for more than twice the combined mass of all the other planets in the solar system. Tyson often points out that Jupiter's immense size plays a crucial role in shaping the architecture of our entire solar system. Its gravitational influence is so powerful that it is often referred to as the solar system's cosmic vacuum cleaner, pulling in comets, asteroids, and other space debris that could pose a threat to Earth. However, Tyson also cautions that while Jupiter's gravity protects Earth from some dangers, it also creates a double-edged sword. It can redirect debris in ways that send objects hurtling toward the inner solar system, potentially putting Earth at risk. This balance between protection and danger is part of what makes Jupiter so fascinating. It serves as a celestial gatekeeper, shielding the inner planets while occasionally acting as a cosmic slingshot. The atmosphere of Jupiter is perhaps its most iconic feature. The Great Red Spot, a massive storm larger than Earth itself, has been raging for centuries. But Tyson reveals that this storm is just one of many atmospheric phenomena on the planet. Jupiter's atmosphere is a dynamic, ever-changing environment filled with powerful jet streams and layers of clouds that alternate between light and dark. These winds, reaching speeds of up to 400 miles per hour, are far more extreme than anything we experience on Earth. Yet the underlying mechanics driving them remain a mystery. Scientists are still working to understand how these fierce winds and powerful storms are formed and what they can tell us about the workings of giant planets. Tyson emphasizes that studying Jupiter's atmosphere is not just about understanding this planet alone but also about gaining insights into the behavior of other gas giants, both in our solar system and beyond. For years, scientists believed that Jupiter was composed entirely of gas and liquid, lacking a solid surface. However, recent findings suggest that Jupiter might have a solid core, though its exact nature remains unclear. This discovery has piqued the interest of scientists, including Tyson, who points out that the core could be rocky, metallic, or even something entirely unknown. Understanding what lies beneath Jupiter's thick clouds could provide critical insights into how gas giants form and how their atmospheres evolve. As Tyson explains, the more we learn about Jupiter's internal structure, the closer we get to unlocking the mysteries of planetary formation itself. Could the core hold the secrets to how the early solar system developed? Could it shed light on the processes that lead to the formation of planets like Saturn, Uranus, and Neptune? These are the questions that drive scientific exploration. Another inspiring aspect of Jupiter is its magnetic field, the strongest of any planet in the solar system. This powerful magnetic field generates a massive magnetosphere that extends millions of miles into space, capturing charged particles and creating radiation belts that make the environment around Jupiter hostile to spacecraft and electronics. Tyson often marvels at this phenomenon, explaining that the magnetosphere is likely driven by the movement of metallic hydrogen deep within Jupiter's core. Metallic hydrogen is an exotic and rare state of matter that forms under the extreme pressures and temperatures inside Jupiter. Studying it could revolutionize our understanding of material science and physics. Jupiter's magnetic field not only influences its own environment but also provides a model for studying the behavior of magnetic fields on other planets, including distant exoplanets. Jupiter's moons are another treasure trove of scientific discovery. With at least 79 known moons, the planet boasts some of the most intriguing bodies in the solar system. Among them are Europa, Ganymede, and Io, each offering unique opportunities for exploration. Covered in a thick layer of ice, Europa is believed to have a vast ocean beneath its surface. Tyson highlights that this subsurface ocean may harbor life, making Europa one of the most exciting targets for future space exploration. The possibility of microbial life existing in Europa's ocean is a tantalizing prospect that could redefine our understanding of life's potential beyond Earth. The most volcanically active body in the solar system, Io is constantly reshaped by eruptions fueled by the tidal forces exerted by Jupiter's gravity. Studying Io provides a unique opportunity to explore geological processes that differ vastly from those on Earth and could shed light on the mechanics of volcanic activity on other planets. The largest moon in the solar system, Ganymede, has its own magnetic field and, like Europa, is believed to have a subsurface ocean. This makes it yet another compelling candidate for the study of extraterrestrial life. Tyson often emphasizes that Jupiter's moons are not mere satellites, they're worlds in their own right, each offering unique characteristics and the potential for groundbreaking scientific discoveries. Beyond its role in our solar system, Jupiter serves as a model for understanding gas giants orbiting other stars. Tyson often draws parallels between Jupiter and exoplanets, explaining how the study of our gas giant can provide valuable insights into the atmospheric composition, magnetic fields, and potential habitability of distant worlds. Jupiter's majesty and mystery have inspired generations of scientists and enthusiasts. Tyson often speaks about the importance of curiosity and exploration, urging us to look to the stars for answers to some of life's biggest questions. The study of Jupiter is not just about understanding a distant planet, it's about understanding our place in the cosmos. As missions like Juno continue to uncover new details about Jupiter, we are reminded of the boundless possibilities of scientific discovery. From its swirling storms to its enigmatic core, from its magnetic field to its captivating moons, Jupiter remains a symbol of the vastness and wonder of the universe. And as Tyson so eloquently puts it, when we study Jupiter, we are not just learning about a planet, we are exploring the history and future of our solar system, and perhaps, the cosmos itself. Please like, share, subscribe and comment. Thanks for